Hello everyone! So in this video we are going to be talking about the mechanism of enamine formation. Now enamines are very similar to imines both structurally and mechanistically. The only difference structurally is that enamines contain a carbon-carbon double bond, which then one of those carbons is single bonded to a nitrogen, and they are formed from secondary amines and an aldehyde or ketone versus a primary amine and an aldehyde or ketone. Now, in addition to having a secondary amine and an aldehyde or a ketone for enamine formation, our aldehyde or a ketone must have at least one alpha carbon that has at least one hydrogen bonded to it, and we will see why as we work our way through our mechanism. One nice thing with this mechanism is that if you know the mechanism for imine formation, you know basically the entire mechanism for enamine formation, as they are the same with the exception of the last step. So I have our example here that we will be going over: our ketone, our secondary amine, and finally our enamine product. So let's jump right into that mechanism. So here we have our ketone. We are going to add our nucleophilic secondary amine along with H+, and that nucleophilic secondary amine is going to attack our electrophilic carbonyl carbon, pushing some of those electrons from the double bond up onto oxygen, which leaves us with a single bond and a negative charge on oxygen, and our new bond to our amine group, and that amine group is now positively charged. Next, we are going to add an acid, which is going to protonate our oxygen. So oxygen gets protonated in that step, leaving us with an alcohol group. And our amine group is still the same since we haven't messed with that yet. Now, if you remember our little trick from the imine formation mechanism, we are going to protonate to get rid of and deprotonate to keep. So, like you can imagine from looking at our expected product at the start of this video, we're protonating our oxygen because we want to get rid of it. We want just that nitrogen group to stay on our molecule. So next we are adding a base, and that base is going to deprotonate our nitrogen, making that nitrogen neutrally charged. With its one lone pair. All right, so next we are going to add more acid, which is going to further protonate our oxygen, turning that group into water. Now, water is a really good leaving group, so that is going to leave our molecule, leaving us with a carbocation. Next, through resonance, those electrons from the lone pair on nitrogen are going to drop down, forming a carbon-nitrogen double bond. So we form that carbon-nitrogen double bond, making the nitrogen positively charged. Now remember where I said our last step is a little bit different from our imine formation? That is because since there isn't a hydrogen to remove from the nitrogen to get it to be neutrally charged, we can remove an alpha proton instead through the addition of a base. So I'm going to take this alpha proton from right here, and our base is going to come and pick that up, allowing the electrons from the carbon-hydrogen bond to form a carbon-carbon double bond, and that is going to push electrons from the carbon-nitrogen double bond back up onto nitrogen, Now, this leaves us with our enamine product. So like I said before, remember, like the same as imine formation, we are going to protonate to keep, deprotonate to get rid of. We protonated our oxygen a couple of times to get that into a good leaving group, so it would leave our molecule, and we deprotonated nitrogen and that alpha carbon in order to keep that amine group on our molecule. All right, so now I have a practice problem or two. Looks like two practice problems for you to try. The first one, you're given your ketone and your secondary amine, and you have to predict the enamine product. And for the second one, you are given your starting material and your product, and you have to figure out what the secondary amine was that was reacted with the ketone to form that product. All right, so these are the answers that you should have gotten to those practice problems, and thank you so much for watching.